recording is on. Okay. So we are now recording. Audio is good. I assume you guys can hear me. So let's start. All right, so you should be seeing the Brightspace environment. You can see here. So we are going to talk about SNMP today. So last week we talked about the file system and file system analysis, right? And then we also did some scripting, you know, case Aurora and other scripting examples, right? The scripts, the link is there. Now, today we're going to talk about this topic in network management, network monitoring. It's a sysadmin. It's a pretty important topic. This is a protocol that has been around for a long time. Now a lot of companies like Windows, I've heard Windows Server now basically sells this as an add-on to make money. So we are, you know, it's a big topic, but we're going to take a look at how it works. Should be pretty interesting. So I have some slides here. So let me actually start with the lab, just kind of motivate this. This lab you will have to do, okay? But it's a very easy and very fun lab actually. So we can take a look here at the lab document basically. So it's loading. And you can see here. So basically the lab, kind of to motivate, the idea is that you're going to configure SNMP. Very much like you did with the DNS lab where you configured a client and a server. Here you're also going to configure a client and a server. And the idea is that you have one, like a manager, and then you have an agent, right? And so the manager can monitor the agents basically. And that's really the idea. So, but you know, this will become clear as I go through the slides. So in the slides, basically, this will become a lot clearer. So here you can see, it's basically you just follow the directions to configure. I will do a couple of scripts, but this is pretty easy. There won't be any homework for you to do in scripts. I just want to show you that you can actually write a script that also queries SNMP. So, you know, then configure the manager, and then you get these really nice things, right? So you're going to get we're going to use a tool called Cacti. It's a Linux-based tool for monitoring. So basically with Cacti, you could also write your own code for this, but basically you could monitor servers, printers, any kind of network device in your network, and
Professor, if you're still talking, we can't hear you.
I think oh.
Did we just lose him?
No, he's still here.
He's muted.
can you guys hear me now, guys?
Yes.
Yeah.
Okay, you can hear me now?
Yes.
Yeah.
I have a question. Have you heard anything I've said since we started class?
We heard
Yeah,
the first couple minutes, and then you cut out maybe about a minute ago.
Yeah, it was roughly a minute.
Oh, just a minute. Okay. Sorry. I don't know. I got a new microphone because the other one always has static. Can you hear me now, guys?
Yeah, it's kind of echoey.
Echoey? All right, how about now? How does that sound?
We can
You
barely
sound
hear
far
you.
away now.
Yeah.
How about now?
Nope, still super far away.
How about now?
A little better.
A little better? All right. Like I said, I'm using a new microphone, and I don't know, it doesn't. So is this okay enough, or what? Does this sound okay?
Yeah, it's fine.
Fine.
Yeah, I never heard a problem with your other microphone, honestly.
The other one just had a scratchy noise always in the background. There's a scratchiness. I don't know if you noticed it in the video. So I'm trying to get rid of that scratchiness by using a microphone. But so what I want to know is this okay to continue? Continue with.
I would say it works.
Yep.
They work. Okay.
It works. It's a little echoey, but you know, you can prevent time.
Little echo.
Professor, real quick, I still need a group for the final project.
Oh yeah, guys, what about now? The volume, is it still echoing?
The volume's great. You just have like an echoey quality to it a little bit.
I honestly don't remember if I'm in a group or not.
All right, so who needs a group, guys? Let me pause the recording here. All right, so we are now recording, and I'm going to switch over to the Brightspace environment. All right, so when we cut out, I'm not sure if you guys heard anything about this, but this is what I was saying is what I loaded here is the lab itself. Okay, this is the lab for SNMP, the Simple Network Management Protocol. So you can see that there. And it's really simple. You just have to configure a tool called Cacti, and it's a nice monitoring tool. So you'll follow very much like with the DNS lab. Hopefully you're starting to see a pattern where you always configure like the manager and the agent, or the server and the client, that kind of thing. So you're going to have a computer, you're going to configure the agents first with SNMP. Then I'll do some scripts, but it's pretty easy, pretty straightforward. And then you'll configure the manager. And then ultimately what you want to see is you want to be able to query anything from a computer, right? So you want to be able to query anything from a computer, all the variables. So we're going to see that computers actually, you can query anything about them through this protocol. And then you can keep track of the information. So you can see over time something like this, where you go from, over time, Saturday, Sunday, and so on, and you can see the utilization. So for instance, for some local host, the computer named localhost, you see the memory usage over time. And this allows you to do some great monitoring. This protocol, as I said, has evolved so much, and it's so useful that companies like Windows, with their Windows server, they actually want to sell you this as a company. Because as you might imagine, these reports are very useful, right? So a lot of people, the reports are really where the money is, creating reports for all kinds of things, for business in general. So that's the general idea. And so this requires, the configuration is in Linux, but it'll be pretty straightforward, actually, I should say. And you guys then will create a type of a network operations center, if you will. We talked about geolocate last week. That kind of ties into the topic as well. If you think about it, the theme at this point is just to monitor the network, monitor everything that's going on in your computer. All right, so this will be a lab, one single lab. We're not gonna, this Wednesday we'll do the account management lab. Next week we have the exam, and then that Wednesday we're gonna come back to SNMP, wrap it up, and then I'll assign the lab for that one. The account management also, because you have the exam, I'm gonna kind of, even though I'm gonna have you start on it, I'm not gonna give the deadline just yet for the submission. It'll be after the exam. Okay, so I have a question here. How many labs do we have left? We have probably the SNMP, the account management. I think there's a firewall lab. I think there's only 3 labs left, I believe. So I'll have to check, but you know, not many. All right, so now though, before we get into the lab, obviously we have to understand this SNMP protocol is very historical, right? So it's got a lot of history. And so we got to look at some of the details of it. All right, so I have a set of slides. So we're going to go back to the table of contents. And we are here, right? So we are. Yeah, so there is something about, as you said, Apache, Python, PySNMP on the calendar. It is also SNMP. So what that is Python PySNMP is how could you write your own SNMP tool, but I may only make that lab optional instead of required, okay? So that's really, but we haven't gotten to it. I'm looking at the time right now and I'll have to make that decision. Definitely the ones that I must make required are the SNMP one, and the account management is extremely important for the Hadoop. And then probably the firewalls one is kind of an interesting one. So anyway, Linux firewalls, I should say. So yeah, all right. So let's get started with the slides. I'm sharing the right space, so you should be seeing this link here. These are the slides basically, and that's what we're going to do. Right. So, yeah, that's what we're going to do today. So let's open up, and I need to download this actually. So let's see. I need to download it. All right, and then open it. All right, so now I'm going to share these slides. Okay. All right, there we go. So hopefully you're seeing now the slides for the topic of today. As I said, as part of your class, sysadmin and management, this is a pretty important topic, and it's a good way of start with just SNMP itself. So the simple network management protocol, right? So pretty much the name tells you everything, right? So it's simple. It really is actually. It's one of those things that they created, and then they said, well, this is just a temporary fix. We'll get it right the next iteration. And it kind of just became, you know, they kept using it like that. And over time, it has been modified. The very first version, which, as you might imagine, came out, 50s, 90s, sorry, not 50s, the 80s and 90s. So it wasn't very secure. That wasn't such a big concern back in those times. But over time, it has become, it did get a little bit more security, more performance, etc. But actually, the principle of it was pretty good initially. I should mention other tools actually use the same logic. Okay, the same logic. So let's take a look at it then. So the simple network management protocol, as it implies, it is a protocol just like other protocols that you know in networking, right? TCP, IP is that type of a protocol. And the purpose of it or its goal is for network management. In particular, it can actually do two things. It can, let's say that you have a device, so in a sense like Active Directory, right? Like Active Directory where you can kind of manage a computer from another computer and change parameters for it. They both share the similar ideas. SNMP was meant to you know, you have a network of computers. You know, you have several computers in your network, and then you have a central computer, let's say the manager, and these are agents, right? And so what could happen is usually these computers report back, okay, report data back to the manager, right? And then the manager can take all that data, summarize it, and you can view it. Another thing that can happen is that the protocol does work in the other direction. The manager can actually send commands to the devices and change parameters. So this is called read and write in the language of SNMP. However, it is not recommended that you write because it's a little bit insecure. This protocol is a little bit not one of the more robust protocols. It's only for internal use in an internal network, but usually write is preferred not to be done. And you'll see, I'll show you guys in the lab how this can be done. But read is, you know, read is something that can be done, right? So you can view the data. So that's really the idea with SNMP. It was created, you know, back in when it was created for this very purpose, okay? For this very purpose, okay? So let's take a look at it now. So before we talk about SNMP, we can actually talk about network management itself, okay? So this could be implemented, you know, there's a protocol that works on the Linux side, on the Windows side, etc. You know, in this course, we focus on Linux, so we'll take a look at just the Linux side and how we can configure this. But we could actually, you know, the manager is Linux, but the agents can actually be printers. They can be a Windows machine. They can be a Linux machine. So you can configure whatever you want. In this lab, you will need to configure at least 2 computers. So you'll need to have your local machine. You'll need to have a clone. So let's say it's a Linux VM and a clone of the Linux VM, plus also a, you know, maybe you can configure the Windows machine, etc. And they all just need to talk to each other. All right, so now that, you know, before we get into SNMP protocol, let's just talk a little bit about network management in general, right? So you know, you guys know what the network is, obviously. So any computer that has an IP address, basically, or, you know, that communicate over the network. And you know, in sysadmin, what you want to do is make sure that the network is a living, you know, almost like a living entity. You want to monitor its metrics, its performance, and that's the goal. So so what are the basic tasks, therefore, that fall under this category? So we'll start there. So the idea is that you want to be able to monitor things related to the network. So configuration management, keeping track of device settings, right? Device settings and how they function. Fault management, dealing with problems and emergencies, right, in the network. So the router stops routing, server loses power, etc. You want to be able to monitor these things. So you can get like an alert, you can get, you know, it has nothing to do with cybersecurity, right? The goal of this is just to know, you know, did a server go down? And we've already done this, right? So we already had that script initially at the beginning of the semester where we could just, we wrote our own nmap, right? You know, my nmap. If you remember that script, we could see open ports, we could see little things like that. Well, instead of writing those scripts, so that you can just take solutions like these that already do everything for you. You just have to specify the data that you want. And that will be actually the purpose of the lab. You'll configure the service, and then you're going to create these templates, and then you have to visualize some data, okay, of your computers. Obviously, this requires that you leave it running for a little while because this collects data over time. All right, another thing that network management wants to do is it wants to look at performance management, right? So it wants to know how smoothly is the network running? can it handle the workload it currently has, right? So again, these are just statistics that you can collect with this type of service, okay? And that's, that's the goal. We can, there's several ways in which we can take network management and just divide it into functional areas. So what that means is that we are going to, take a look at, how can we use it, right? So as I said before, here's a list of a few more things. So configuration management, just first of all, keeping track of the inventory of your equipment, but also keeping track of the configuration. Then fault management, also reactive and proactive if there's a fault in the network, right? So a little bit of reliability there, right? So you're looking at reliability there, and this. Now I should mention that this only deals with collecting the data. We're not actually, so when you're dealing with data in general, right? When you're dealing in data, there's collecting the data, and then there's analysis of the data. This protocol, our discussion, our lab, everything that we're going to focus on does not really cover anything related to analysis, right? Doesn't really cover anything related to analysis, but it does cover everything or a lot related to collecting the data and visualizing the data. So you can visualize your data basically, okay? You can visualize it. But no analysis here. That analysis is kind of left to you to figure out, using your own reasoning skills. So performance management, as I said, so that just has to do with the number of packets dropped, timeouts, collisions, errors, right? So all this data can be gathered and visualized. Now, SNMP is not for security at all, so SNMP does not provide much here. Okay, it's not a cybersecurity or anything like that tool. However, I should say the protocol itself can be a little bit insecure, so you need to be very careful when SNMP is running in your network. Accounting management also, so obviously if you're collecting data that can help you with cost, right? So you can justify things. Asset management, so you can have statistics of equipment, that tells you when an equipment starts to fail a lot, that you need to replace it. Allows administration of personnel, the facility, etc. Right? So it's a monitoring tool for that as well. And planning management, which basically means analysis of trends, right? So you can, if you look at the trends, then it can help you to justify a network upgrade, right? A bandwidth increase. So you can see, well, we've been monitoring the network over the last year, and we can see that the trends are going up. Therefore, eventually, we're not going to have enough resources for the network, so we need an upgrade. And this helps you to create documentation. You saw yesterday how, not yesterday, a week ago, how we can actually create reports and everything. So that's the same idea here. This does not have reports built in, but there are a lot of companies out there that sell you, kind of this, on top of SNMP, a set of basically reports that you can visualize. Okay. All right. Okay, so let's move on to the next slide. So what is SNMP? So we're going to start here with SNMP. We're going to define it as is a tool, right? It's a tool or a protocol that allows for remote and local management of items on the network, including servers, workstations, routers, switches, and other and other managed devices. So basically, really, you can think of the scenario where you have an organization, and then the organization can have a centralized room, if you will. And in that centralized room, you have an SNMP manager. And then that SNMP manager will query all the SNMP agents, collect all the data, and it has the data now, so it can actually visualize it. right? And then of course you can do all kinds of things with that data, like write reports and so on. All of it, the common theme is that it's going to be network data, okay? So it's going to be network data. Question?
That was-
All right, so then we have, now we're going to have the terminology of agent and manager, okay? So we have the terminology of agent and manager in this idea, right? Excuse me. And so we have agent and manager. The agent is the process running on each managed node, collecting information about the device it is running on. Okay. So basically, you have a printer. The printer could have an SNMP agent, and it's going to collect a lot of information about that agent. It could be potentially thousands of variables, right? Of that, and that data is sent across the network to a manager. Now, keep in mind, that's a lot of packets being sent into the network, so there are some issues of sending a lot of traffic in the network as well. Now, the manager, on the other hand, is a process running on a management workstation, usually one or a few, not all, and these workstations request information about devices on the network, right? So they get data back, okay? So that's the idea, which is pretty straightforward. So what are some of the advantages of using SNMP or tools like SNMP? I want you to understand people could come up with their own tools for SNMP. That's why at some point we'll show how to do this with Python, just to kind of get an idea of how that would work. But at the end of the day, the logic is pretty consistent. I mean, I haven't seen a solution that is very, very, very different from how SNMP approaches this problem. And so that's why it makes sense to look at SNMP itself. And it's because we look at the protocol and how this one works as an example. So the advantages of using SNMP, of course, it's standardized, so it'll work on Windows, it'll work on Cisco devices, Linux devices, all kinds of things, right? So that is always something desirable, because you want to monitor everything in your network, not just the Windows computers, for instance. It's great if you can, monitor the routers and the switches and so on. It's universally supportable. In particular, it's extendable, and you will see how it's actually the data is separated from the protocol. So there is the protocol of the queries and getting the data and everything, and that's one thing. And then there's the representation of the data structures for the data, because when they created something like this 20 years ago, let's say, they didn't anticipate maybe iPhones, right? And they didn't anticipate other devices that now you may want to query as well, right? So whatever it is. And so you need it to be extendable to future technology. What about the Internet of Things, right? So you guys have heard of the Internet of Things. So what about this one? You might want to monitor your devices, PLCs, etc. It's portable, so you can apply it to a lot of things, a lot of devices. It allows distributed management access, so it's obviously in the network, so you can manage it.
Professor, you muted yourself again, if you didn't know.
Professor, I think your microphone went kaputzi again.
It could be his internet too.
Or maybe both.
He's still streaming. Oh, no, he's not.
Yeah, if he's still in the chat in the group, he should be fine. Yeah, he's still here.
Can you guys hear me now?
Yep.
Yep.
Yes.
Yep.
I don't know.
Now
I
we can hear
think I'm going to switch to the old microphone. I'm not muting it. It mutes itself somehow. So, okay. All right. So I'm back at the other. I just had a class. In the previous class, I used that microphone with no problems. But anyway, sorry. All right. I'm going to stay with the old microphone. Okay. So is this the sound level okay here?
you. Sounds more clear.
Okay. All right.
Yeah,
So
it sounds good.
all right, so let's go with this one then. All right, hopefully there won't be any more problems. All right. I'm back to slides, okay? So again, if there's a problem, just let me know. All right, so we were talking about SNMP here. So this protocol exposes management data. Basically everything is a variable. Oops. So everything is a variable on the managed systems, okay? And you'll see that. This is associated with a data structure called MIB, not to be confused with the Men in Black, right? So it's got another meaning, but that's the name of the data structures. And all information is referred to as a variable in a system. And so the MIBs are going to be these data structures that for, let's say, Linux Ubuntu 1604, it defines a template of all the variables that you can query via SNMP in Linux Ubuntu 1604 or 1804. Let's say you have a printer and it's a Hewlett-Packard something. So then Hewlett-Packard would define the MIB, right, for that printer, that particular brand of printer and version of printer. And that data structure would then have a list of all the variables that could be queried for that printer via the protocol itself, right? So that's really how it works. So, you have variables that allow you to describe information about the system and describe the system configuration and so on. And these variables can be queried and sometimes even set, although setting these variables can be a lot more dangerous, as you might imagine, because of security. Imagine if somebody takes over your SNMP protocol, a hacker, they could then shut down your entire network, right? Because they could just send, every variable in the computer could be reset to something and the whole network would crash. I mean, that's literally like, a terrifying prospect. And so if they just took over the SNMP protocol. So that's why setting is a little bit of an issue here, but querying it, on the other hand, which is just reading the data and viewing it, that still works pretty well. So they can be queried by managing applications. Okay, so that's the idea. So so an overview and some basic concepts. So SNMP agent shows data of interest on the managed systems, right? So things like, as we saw in the lab handout, when I was looking at it, we looked at memory usage. If you think about it, so that's the same idea here. So variables such as, free memory, what is the system name? You guys actually, when you do your lab, you'll get the system name, number of running processes, default route. It actually, the list goes on. It could be thousands of things. It's really, pretty much everything, right? So it's pretty much everything. And so it's pretty amazing, actually, very interesting. So variables are accessible via the variables that are accessible via SNMP are organized in hierarchies, right? So, very much like the file system hierarchy. So they're just like tree data structures. And these hierarchies and other metadata are described by what is called the management information bases, or MIBs, right? Like I said, so the MIBs are kind of separate from the SNMP mechanics, right? So there's like the querying and writing or whatever, those protocols, and the MIBs are a separate set of files basically that you can increase, define, etc. And sometimes you can call them templates. So when you do your lab again, you will have to select like a Linux template, like a generic Linux template that all Linux systems have, and so that you can query some of the variables of your Linux operating system, for instance. And these MIBs, basically what they provide is they provide the description of each variable, the type of the variable, and what it's used for, okay? The type of information that it can hold, okay? So, you know, SNMP in its most basic form, okay, so now we can think about the mechanics of the protocol itself. In its basic form, all it does is a packet is sent, a simple packet, right? So the just very much like the DNS lab, right? So if you remember, we did the DNS lab, and this is very similar. It sends out a packet. So it's sent to a network device, such as a router. You know, the router obviously needs to be an SNMP agent, so that the protocol needs to be enabled. And then it'll have a quick question like a get, right? So it's basically get variable. So for example, one might ask, what is the value of, you know, IF just means interface, so interface MIB interface out octets for interface 1, right? So how many octets did it send out, right? Or let's just think bytes or whatever. So how much data it was sent out. So it'll query that and then it'll get a response, right? And that data, you know, the protocol has, Cacti in particular has built-in functionality that allows it to collect the data over time, save it in a database, and then it's going to start plotting the information in little graphs, right? So that's why we saw that really nice graph where you have the data and, you know, you got the utilization and all of that. So that variable is in the group of interface related things. So the hierarchy is that you organize everything as a tree. So for instance, you get to a node of the interfaces, and then you have everything about interfaces. Then you get to the node of this or that, and you have all that data as well, okay? All right, so once the packet is received, let's say by the router then replies with a packet containing the value. And it's that simple, right? It's that simple. And there are variables for just about everything and every kind of technology. And that's where the MIBs come in, because you can always generate more MIBs, and as long as they follow the appropriate structure, then you can query those devices. You know, the protocol needs to be set, and then that's it. So an overview is basically, you know, you define a mechanism for remote management of the network devices, routers, and bridges. And the fundamental principle of it all is that all device management is done by simple variable value manipulation. Okay, so you have this data structure and the MIB of all the variables, and then that's it. You just exchange information about these variables. Right, so the approach is then you need to figure out, you know, the formatting, if you will, right? The standard means of specifying quantities recognized by devices, and the protocol of requesting, returning, notifying of changes of the values. That's it. You know, it's a protocol for the requests, you know, the queries and the responses. So basically, it's like the how, right? So you have a manager, you have an agent, and first you need to figure out the how, which is, you know, the questions, and then the what. And the what are defined by the MIB, right, for that device. So if this is a printer, Hewlett-Packard, right, then printer, Hewlett-Packard, whatever the model is. And so you then are able to query the data, and then here on the manager, the data is collected, and you can even print it out, you know, kind of in a website type of a form, so that you can visualize it really well. Okay, so you can visualize it really well. All right, here we have a nice little diagram of the protocol is not that complex. I mean, I've pretty much at this point given you the overview, the main ideas of it, and really we're just going to, you know, the rest is just kind of getting into the details of it, so it should be pretty clear. So I think, you know, we'll cover the lecture in the lecture today. I don't think that this lecture will take longer than today. And then, as I said, we'll do the lab, the corresponding lab for it. Okay. All right. So basically, here we have the SNMP components, computer running management software with a GUI, so that, you know, you can think of it as this one. This is the management station for SNMP. Then this is the network, and in the network, you might have a host. You know, you have a host, you have a printer, you have a router, you have some kind of a network bridge, whatever it is, all kinds of devices that have IP addresses in the network, but they are all running an agent. So you need to configure them because there's got to be like an encoded, secure, you know, exchange of a password or a key or something. Remember, this is only in an internal network, not in the internet. Okay. So, so that's the general idea of this. And then all of these devices basically provide responses to, you know, back to the manager, and then the manager collects the data and visualizes it. Okay. Remember, it's only data. It's not data like from logs or anything like that. It's just data from variables defined in these MIBs. So all of these need to have an MIB associated with them. But what's great about the MIB is that there is a syntax, right? There is a way of creating an MIB. So that's one of the things. There's like a language, a syntax language on how do you define new MIBs. Okay, that's really one of the key concepts here. So let's take a look at a little bit of how it works. So an example of SNMP, as you guys will do in your lab, this is actually something you will do in the lab. So you can just go to your Linux machine, go to the terminal right there, right? And then you type some commands, right? So you can type those commands. Basically here, you know, we can dissect this command. This will only work, though, after you've configured SNMP, right? So wherever you do this, that's an SNMP manager, right? That's the SNMP manager. You need to provide a password. Usually the password historically has been called public. So when you say, and it's called, and the C stands for, I don't know, the community string, I think it was called traditionally, but it's like a password. And so you send that password. Here you just specify the version of this. So in this case, it's version 1. And then you just specify here the computer, right? So in this, you know, let's say stevens.edu or whatever, some server on the internet. This can also be an IP address, 192.168.1.7, something like that. But really the elements are that you need to provide the community string. This is something that you need to define, okay? When you're doing the configuration, you need to define this password. This is the version, and this is just what you're querying. When you do, this query is called the SNMP walk, and what the SNMP walk does is that it will, an SNMP walk basically walks through the MIB. So for this computer, let's say that this computer is, you know, your Linux machine, right? So then you're gonna basically walk it, and this will just, it doesn't even care about the template. It'll just, everything that's a variable for this machine, for SNMP protocol, it'll print out. And you can see the output here on the terminal. So it print, you know, this ... just means, oops. What just happened here? Okay. So this ... it just gives all the data basically that you have in that MIB. You can see, for instance, here it starts to print out information. So for instance, here, look at this one. We started the semester 372 with system uptime, right? If you remember, that was one of the first things that you got from a computer. Okay, so you got this, the system uptime from a computer, you know, at the beginning of the semester, and just tells you how long this has been on, right? So 32 days, the uptime of the server. And then there's a few other things that it can print out, like an ID, for instance. It can print out, this is the description of the object. So you can see it's a HP, Ethernet, multi-environment, you know, jet direct, whatever. So it's a printer, right? So this is a printer, right? And it just gives, you know, whatever information you have there in the protocol. So everything really, when you think about the protocol of SNMP, you know, of the ideas of SNMP, you can call everything, you know, you got basically a network, right? So you can think of it as a network of nodes and links. Okay, so you have nodes and links. Items in an SNMP network are called nodes. There are different types of nodes, so they can have managed node or managed nodes or management nodes, right? So really, managed nodes typically runs as an agent process. So it runs as an agent process that services request from a managed node, right? So a managed node will go to these machines and will ask for specific information. The management nodes are the ones that request the data and then are going to display it. So typically a workstation running some network management and monitoring software, like Cacti, for instance, for a lab, will run on the management node, right? The managed nodes do not need to have the display on there. All right, nodes that are not manageable by SNMP. So this could be, you know, other computers that, you know, that are not, but somehow you create a proxy agent that queries that some information from them and then converts it into SNMP type of protocol. So that's another possibility. You know, a node may not support SNMP, but may be manageable by SNMP through a proxy agent running on another machine. So nodes can be both also. They can be managed nodes and management nodes, right? So in fact, when you do your lab, the managed machine can also query itself, okay? So here we have another idea of the concept. So you can see here, you know, you have your network basically, and you have, you know, all these devices that are agents. You know, this is an agent. This is an agent. All of them, these are switches, right? And then you have a manager over here, but you can have another manager over here. And they, you know, as long as they share the password and everything, they can monitor the network, because you might have, you know, sysadmin 1 and sysadmin 2, and they both want to take a look at the data, basically. And then you have the agent variables defined in the MIB that can actually be queried. So you can, you know, that's really it. I mean, it's not very much more complex than this. We're just going to talk a little bit about it. Now, if you ever wanted to go into business for yourself and create, you know, your own solution, you know, this is where you would start, right? So you start with this, and then you can start developing your own ideas. You know, so I've already explained this idea of proxy and gateway agents. You know, so I don't need to say that again. Now let's get into a little bit of the basics of how SNMP works. Just not, you know, not the MIBs themselves, but just the operations, right? Let's call it the operations of how the protocol works for all MIBs. So here we can think of there are 4 basic operations, which are called get, next, set, and trap. They're all pretty clear, actually, but let's take a look at them. So get retrieves the value of an MIB variable stored on the agent machine. That variable can be an integer, a string, it can be an address of another MIB variable, you know, lots of things, right? So that's defined in the MIB itself, but you know, that's, you know, get is what allows you to get information. Get next is something that retrieves the next value of the next lexical MIB variable. So when, for instance, the good example of this is when you use the SNMP walk, right? So SNMP walk, you might imagine it's just a series of get next, get next, get next in the MIB. And it allows you to iterate through all those variables, which could be a lot. You'll see that when you run the lab, you will actually be able to get all the information that you want. Set, this is reading, so this is read data, and this would be write data, right? So writing your data there, set. So that changes the value of an MIB variable. Remember, because of security, this is probably not recommended at all. But you know that the capability is there, so you can take a look at it. So it changes the value of an MIB variable, and then you have this thing called the trap. The trap is pretty interesting because whereas if the first 3 come from the manager to the agent, the trap is really the solution when you want the agent to initialize communication with the manager, right? So a trap is defined as an unsolicited notification, right? Sent by an agent to a management application. And it's typically a notification, something unexpected happened, like an error. So imagine you have some critical device, something happened to the device, you know, but it's still on. And so immediately it sends out a trap, and the trap is going to be sent to the manager just saying, hey, something just happened to the computer. You know, my RAM just crashed or whatever. And so when it gets to the manager device, then the manager device could even send out an email, or it could send out a text, right, to notify the sysadmin, hey, you know, something just happened to one of your devices in the network, so that you can actually take action. Okay, so that's really the idea. Remember, all of this, again, in sysadmin, you want automation as much as possible. So remember, that's one of the objectives, basically, to have as much automation as is possible. So the traps here, you can see traps are unrequested event reports that are sent to a management system by an SNMP agent process. When a trappable event occurs, a trap message is generated by the agent and is sent to a trap destination, which is a specific configured network address, right? Many events can be configured to signal a trap, like a network cable fault, a failing NIC or hard drive, a general protection fault, a power supply failure, like if you have some switches that might have 2 power supplies, right? They're critical. And if one fails and if the other fails, you know, the whole network might shut down, or a link. And so immediately it'll issue, okay, one of my power supplies failed, you know, you need to replace it, right? Something like that. You can also throttle the traps so that you can limit the number of traps sent per second from an agent, you know, given that computers in general, that because of entropy, right? You can assume because of entropy that there's a probability that if you have thousands of computers, you're going to get, you know, a lot of faults, etc. And so you could end up getting a lot of traps. So the idea would be to throttle them, to prioritize them to the most critical elements. And then and you can see that here, traps have a priority associated with them. So critical, major, minor, warning, marginal, informational, normal, or unknown. All right, are there any questions so far, guys? Any questions?
I don't have any.
All right, good. So that's basically some of the terminology, and you can see it's pretty much straightforward. There's really not that complicated. Trap receivers, then traps are received by a management application, right? We're going to see that there's obviously going to be some open ports associated with this. Every time a packet arrives at that port, it needs to be of the SNMP protocol. It also needs to be have the authentication parameters and so on. And you probably would want it to be like version 3, which I think is the one that has cryptography, so that it follows crypto ciphers. All right, so management applications then handle the trap. And again, this can vary so much, very much like the reports that people are always going to try to sell you, hey, our SNMP device. But what I want you to kind of understand is that all of this you could build it yourself, right? So don't be too impressed if somebody shows you this solution, because it's not that difficult to make. Okay, and that's my point with this, is hopefully that if you ever come across something like this, you'll see that behind the scenes it's actually pretty straightforward. All right, so the management applications can handle the trap in a few ways. They can basically receive the trap and then pull the agent that sent the trap for more information, right? So they can just say, okay, I just got a trap. Now I'm going to send out a GET to get more information about the event and the status of the rest of the machine. So they can do basically, okay, I just received the trap. I'm going to do an SNMP walk, look at all the data, and then make a decision. They could also get the trap and just log it, right? So computers log pretty much you log everything, most likely. So you log it, and then, or you could actually completely ignore. So if you get a trap, but you kind of know, oh, that computer always sends that trap, but it's nothing critical, you can also ignore it with your system. Management applications can be also set up to send email or voicemail or something like that. So it's fully automated so that the system administrator might get let's say a text message, your server just blue screened at that's old joke, right? So at 3:46 a.m. have a nice day, right? So that's actually could be useful, right? If you have one critical system that cannot go down, this certainly could be useful for you. And that's the great thing about having a protocol, is that you don't have to write the code for it, right? You just have the protocol running in the background. And then, so there's a difference between, let's think about it. We have an agent and then we have a manager, right? So the agent, if it had a protocol like SNMP or something similar, it already speaks this language. It already speaks this language of the variables, the MIBs, the communication. You don't have to develop anything here, right? You just set it up, configure it, it works. And then you make sure on your manager device that you both, let's say, speak the same language, SNMP, and then here you can build whatever application you want. So you just query it, get a response, and then take that data and do whatever with it. Further, you can send messages, all kinds of things. Okay, so there's a difference. You can fully develop this into a lot of things, and then here you just install some protocol without having to really worry about having to develop all these specific agent, the code for all these agents and so on, and their complexities. All right, so now that we've talked in general about how SNMP works, now we're going to think about the management components of SNMP. So to do management tasks, SNMP uses two other protocols. the structure of management information, SMI, and the MIBs, okay? We've already talked about the MIBs, but the SMIs and all of that just kind of gives you the underlying, like the middleware, if you, if you want to call it that, for everything else to work, okay? So let's think of SNMP from the point of view of the architecture and the model, okay? So we can divide SNMP, we can look at it from the point of view of organization, from the point of view of the information that it stores, from the point of view of the communication that is used, and from a functional point of view. So what it does, how it does it, what it carries, and how things are organized, okay? So those are really the ways of looking at this, okay? So the SNMP model then, the organizational model, we've talked about it. It just means the relationship between the network element, the agents, and the managers, right? So the hierarchical architecture, right, that you have in the network. The information model just has to do with these ideas of the formatting of everything, right? So how is everything, you know, it's almost the analogy of like, you know, whenever you learn a programming language, right? So all programming languages pretty much have loops, you know, if statements, those kinds of things, but they all have their own syntax, right? You know, C++ has its own syntax. JavaScript has its own syntax. You know, Python, Bash, Shell, etc. All of these languages have their own syntax, basically. And so you have the organizational model, and then the information model. This, you know, it's got the structure of management, the MIBs, and the ASN.1 syntax. Okay, so those are the things that define how you should create MIBs, for instance, right? Because you're not really, you know, you usually want to get the protocol, SNMP or something similar to it. You don't want to create that one, but you might create the manager application, the MIBs, etc., for your own particular case, if you want to go into the business of system administration like this. There's also the communication model, and that just refers to the transfer, right, of syntax. How do you transfer data? How do you transfer data over TCP and IP or UDP, right? So how does that work? Communication services that use messages, basically. You know, we talked about the packet like get and set and so on. And of course, a very important aspect in the communication model that was not really there in version 1 of SNMP is the security framework, right? How do you provide security? At least you want to have some kind of a password. But if you have a password in the network that is being sent in clear text format, that, you know, that anyone can sniff that password and then spoof packets, very much like the DNS lab, right? Very much like the DNS lab. So that's, you know, a security concern. All right. So as far as the organizational model, this is pretty easy really to understand. You have the SNMP manager and the SNMP agent, right? That's really what you have. So the SNMP manager and the SNMP agent. You can also, we saw the organization where you can have multiple managers querying a single agent. So pretty much the same thing. We also talked about proxy servers. So this is when some device, maybe PLC, you know, I don't know, a robot that, you know, that's, you know, like in Fukushima in Japan, right? Where they have these robots looking at things in that radiated network plant because of the tsunami. So maybe those are connected to the network when they come into the network. So then you'd have a proxy that translates information of the robot into SNMP, and then that can also be queried by the manager, right? And you can just visualize it. So that, you know, I gave you a robot example because I couldn't think of anything more extreme. I'm sure there's a few things that are more similar to just regular computers, but that don't have SNMP, All right, but that's the idea, right? So you want to fit everything into this common protocol. So the great thing about a common protocol like this is you can just, whatever your problem is, right, you can always think in terms of this, and then things start to make sense. Instead of having to make every single aspect of this from scratch, right? Because you want to monitor your network basically as best as you can. So SNMP multi-vendor principles, as I said, there's a lot of vendors out there, companies, Windows, Microsoft itself, that tries to market this product. I don't know what their model is this year, but I know that in the past they've gone away from making this free, which is free in Linux, to making it more of a commercial add-on for the enterprise environment. So the idea, that you would follow the principles is you want an agent for every managed node to run SNMP management processes or something. Everything is organized by variables, which are objects to describe the state of each device. This is very much like how, and organized in a hierarchical data structure, which is very much how Active Directory works as well. So they're very consistent in that. I don't know which copied which. I don't know if it was SNMP that copied Active Directory or the other way around, or everything just came from one, but they're pretty consistent in that sense. The information specification, as I said, you have all these different specifications or formats. So there's the ASN1. We don't have to worry so much about this, but I'll mention it. We have ASN1, SMI, MIB, and the BER. So BER is the basic encoding rule. That's actually the binary. So this is the very low level, just how it works, right? So how things are encoded into binary. Obviously, at a very high level, you have this one, the MIB, the data structure of the variables. This is usually where you will do all the work. And then the SMI just defines the data structures that you're going to have. And then ASN1 itself is just the standard object definition language. So you can think of it very much as the syntax rules. So when you're going to create an MIB, you need to follow a set of syntax rules for it to be created appropriately. Okay? For it to be created appropriately. All right, so let's move on to the next slide. You can see that one there. So this slide provides for us, the information flow, if you want to think of it that way. And it's really about how all these protocols come together, right? So for instance, you have, you have some kind of a manager over here, right? So you have a manager, they want to get some information, they want to collect, to do useful things, right? So they know what they're doing. So you get a managed node, a printer, let's say, it's got an agent process running on it. It's got the device, like the network interfaces, right? So that's a printer. And then there's an object. The object is basically the variable to describe the device, right? So that's the variable that you want. For you to understand how this works, using SMI and ASN1, this provides the rules to describe the objects, right? So when you have these rules, then you can create an MIB. So it's basically the MIB data structure, right, of the objects that can be queried. And then using BER rules, you convert SMI data structures into a sequence of bytes, right? And then this is how information is, how information is encoded and sent out into the network, okay? And that's it, so what those things are is just like the different formatting standards that you follow. We don't really have to, as I said, understand that too much, just, be aware of all this that's happening behind the scenes. So that's then the information model, right? So that's really where we are. And then we can just talk about a few of the other ones as we try to understand the model and the architecture of SNMP. So here, we can have also another thing that can happen as you organize is that, in a sense, you define the structure of the variables very much like you do in object-oriented programming, right? You create like a class of things, and then you can create instances of a class. So for instance, here we have an object class, let's say interface, right? And it's an interface, and then we have actually, if it's let's say it's a firewall, it'll have 3 interfaces, right? The in, out, and then the DMZ. So it's got 3 interfaces. But then you also, in the object type, you define the object identifier. So keep in mind, every variable in the computer will have an associated name to it, but also an ID. All right, so the ID is the object identifier. And then basically the ASN1 and the other ones will specify how things should be encoded appropriately. Okay. So let's talk a little bit about the object naming. So uniquely defined by, as I said, every variable is uniquely defined by a descriptor and an object identifier. So they're basically key value pairs. So basically they're key value pairs here, key and a value. And that's it, right? So you have an OID. This is called the OID, by the way. OID, and then there's the descriptor. And very much the OID is related to the hierarchical organization of your variables in the MIB data structure. So the MIB here is the hierarchy of information about a device. So think of an AIB as a simple database. It uniquely identifies specific information on a specific device, right? So for instance, the object type, the name, and the allowable operations, right? So for a variable, what's the name, what's the OID? Can you query it? What data type is it? All of that information is specified in the MIB. If you were ever, let's say you work for a company and you want to set up a, the MIB, this is something you would do. You would go in here, you have to learn how to write things in that specific formatting, syntax, and then define the data structure itself. Okay. The SMI, the structure of management information, defines standard unique names for objects, right? So it provides that organization. It defines standard formats for objects for use in MIB, such as what is the length, the data type, those specific ideas. Right, here's an example now of OIDs, right? So how do you come up with OIDs? Well, as it turns out, it all depends on the hierarchical tree. So if we think about it, this is a tree, right? And we can see that there's basically a root, which is called the internet. So, this just means any computer, sort of with an IP. So then you have 1361. So that's, 1361. And this is pretty standard, right? And then from here, dot, right? So we go in this direction. That means like management, then .1. So now we're talking about MIB. So this is specified by MIB. And then now you specify what you want. So in this case, let's say interfaces. So it would be .2. And then if the interface itself had other things, then, dot. So that's how you define the OIDs. They just follow, this data structure here, right? And so on. So that OIDs are dependent on their position, really, on the hierarchical tree. Okay. All right, so let's move on to the next slide. So we can see here, you can also set up your own private MIBs. That basically means that you can, it's almost like a domain or something. You buy your own your own sequence, and now you say no one else can use it, just our companies. You can have 1.3.6.1.4. If you notice, it goes into private now. So it's something that, you know, if you want to use this for experimental things, so then .1, and then let's say, you know, Hewlett Packard .11, right? And that's your ID, basically your OID for your organization, and then everything else follows the information that you want to have. Okay. All right. So okay, so that's the OID. So I think it's pretty straightforward. Now, one interesting thing is if you let's say you wanna, we'll do an example of this probably where I have a Linux machine. So I have a Linux machine. Linux agent, and then I have a Linux manager. All right. So if I want to query a specific device in that machine, I can just query it, you know, by the OID. As long as I have the full OID, I can query it. That's the great thing about it. So the protocol is pretty straightforward. You can even write a Python script or any other scripting language. And just as long as you're using a library for SNMP, you'll be able to query the devices, build your own applications, etc. Okay. Then basically we can organize SNMP into 3 parts. You know, the SNMP protocol itself, the SMI, and the MIB. Okay. So now, you know, kind of in conclusion, so SNMP protocol just defines the format of messages and how they're exchanged. So between managers and agents, so the get, the set, the trap, all of those operations, right? That's what the protocol defines. The SMI, or the structure of management information, defines the rules. The rules specifying the format used to define objects, okay, managed on the network that the SNMP protocol accesses. And then the MIB is basically a database or a map of the hierarchical order of all managed objects, the variables, and how they are accessed. So using basically SMI. So you use SMI to build MIBs, right? So, you know, they're just files, but you build, you follow the rules of the SMI, and then you're able to build an MIB. And that's it. That's really at a high level. And then the protocol, that's already done for us. So we don't really have to do much there. If you want an analogy between this and just regular like computer programming, so you have, you know, computer programming versus like SNMP here, you can see that the SMI is the language syntax, right? The MIB is like the object declarations and definitions, you know, like defining the classes or defining the variables. And then SNMP would be like using, you know, the syntax, using the declarations to write your code. Okay, so that's really a good analogy of how all of this works. Okay, any questions so far, guys?
I don't think so.
Oh, pretty easy, right? Pretty clear. All right, so that's so here we have an example of it in action. If you look at it, we have an agent and a manager, right? And so management question is, what is the number of UDP user datagrams received, right? So from the agent. So how does that work? Well, the SMI then defines the integer values are defined via the SMI. Then the MIB says, well, the object has an integer value and is called UDP IN datagram. and it has this OID. And then the SNMP just encapsulates the request in a GET request, right? And that's basically it. So if we look at it, you know, there's the request, the manager's gonna make it, you know, it looks at all of this, right? So to figure out what it wants, then it sends out, it gets that information, sends it out to the agent as an SNMP GET request, right? With the OID. The agent then understands it because it has that MIB, and it just provides an SNMP packet response. Okay, and that's basically the process. And then you have your answer. All right, so we've talked about all of this. I'm gonna skip this part because I don't wanna go so in depth into that. But there's an example here. So if you look, there's an example here of how you define an interface. So using the ASN1 and SMI, this is how you would define on an MIB something. So for instance, you say interface number, right? And then you specify the object type, that its syntax is an integer, it's read-only, mandatory, that should be there, a brief description, and the name, right? And you can see there it's got specific syntax that should be followed. That's it, right? So if you wanted to build your own MIB or modify it, this would be the approach to take. So like, let's say that you wanted to, for your term project, right? You wanted to query Raspberry Pis or query, Raspberry Pis or some other device. You know, you could create a specific MIB for that Raspberry of some variables that you want. You follow this, and then you can query it from the manager, a regular Linux computer, your Raspberry Pis, just to see how they're doing, and that way you can monitor their information. Okay. So the objects are identified, variable names are aliased. So the interface basically is actually going to be this, right? So remember, it just follows the path in the hierarchical data structure. Okay, you can see that there. So it really follows, you know, 1, 3, 6, 1, 2, 1, right? And that's kind of the, and then in there it goes into the interfaces, as I showed before. All right, this is just another example of the encoding. We don't have to get into too much detail there. You can see that's just examples. Now, the last part just has to do with the packets themselves. So we're almost done with this. So the basic idea is this is the packet. So you have the packet body and the headers, right? So you provide like a length, version, and the community string, which is basically the password. Then you have, you know, whatever the SNMP protocol defines, but you just craft, you know, the packet this way. And then the protocol uses UDP, so you can see here the way that it works. If we think using the UDP protocol, you can always, when you configure your SNMP in your Linux server, you can always do an nmap, right? Or you can do a netstat -NA pipe grep UDP and look at the UDP ports that are open both on the agent and the manager. As you can see, the manager will create a port where it can send out requests, get next request, bulk request, set request, and so on. The agent will be listening on a specific port, UDP port, and then the agent can send back out responses, and remember that it can also send out traps. Okay? Now, another thing that the manager can do is the manager can communicate with another manager, right? Because maybe they want to sync the reports or they want to collect requests from another manager. So there's also that functionality. But in essence, this is, you know, the communication side via UDP between the agent and the managers and everything that can happen between them. We can skip this part. We just talked about how things, the burst structure just shows you how to take things and convert them into the binary, we don't need to worry about that. Okay. And so that that was the communication model, and we've pretty much at this point looked at everything. So we have the manager here, the agent again, and you can see how we have the physical layer, data link layer, IP, UDP, and then SNMP on top. Okay, and then we have the individual things and their direction. But I like the other diagram a little bit better, the one we just saw previously. Now, the few things to wrap up this topic is I should talk a little bit about the security of it. So obviously, the password is called a community. So the idea was that you had communities of devices, and you specify the access to specific variable sets, which could be read, write, read only, or none. You need to supply a community name as password, and usually that's public. The word public, but so that's what you'll probably see in your lab handout, but just keep in mind that can be changed. Now, for the longest time, it was unencrypted in a version that was still used, and that's because it was sort of okay because it was in the internal network, but at the same time, the protocol has been updated now to have encryption incorporated. Here, basically here, these are the port numbers, 161 and 162. You can take a look at those. When you configure your lab, as I said, just Nmap or Netstat and take a look at what ports are open once your service is on. If it's not working, and when you check the ports are closed, well, that's your indicator as well. All right, so you can read through this, but basically, these are the port numbers and the functions. What else do we have here? So you can see how the ports work. So in a client, opens port 162 on the server and 161. So then the server will open some port and send information to the client, like a request, or in this case, a trap actually. But let's just say something like that. So obviously traps usually will go to one of these two ports, but if you're initializing something, you would initialize it with any random port. That's perfectly fine. All right, and that's it. This is just a summarization that we started with. So we use SNMP for configuration, fault management, performance, security. And then here's just the rest of this is just a history. You can take a look at it. Talks about versions 1, 2, 3, and how over time basically things were improved in terms of security and also performance, and a few other functionalities. You can see that there. Version 3, provided more important security features like message integrity, integrity basically, authentication, and just confidentiality to prevent snooping and so on, sniffing of the packets. All right. Obviously, remember that, as I've said before, SNMP is a protocol. A lot of company, there's a big business of providing monitoring services to your network, and so that's a big industry out there for that. We talked about security, right? Basically, some recommendations. Disable it. Definitely this one is not one service that you want to have enabled if you're not using it or if it wasn't configured. Definitely do not allow write unless you absolutely know what you're doing, and just read, at most, and then, always patch your services, etc., for updates. And here, just, to wrap up, here's just some examples of. This is just some vendors out there that like to sell these types of products, and you can see what they do. They provide really nice dashboards with a lot of functionality. sometimes some other related tools, but the SNMP walk, MIB, node viewer, graphing, browsing MIBs, if you have traps, etc. Here, for instance, we have the example that they brought up. This is a catalyst, some kind of a switch. There's the community string, the OID. And then for this catalyst, you're just looking at all the variables, right? Their name. So instead of looking at it like we saw with the SNMP walk, you just get an output on the terminal. Here it's a little bit nicer because it provides the OID, the reference in the MIB, the name of the interface, or sorry, not the interface, the name of the variable, the type, like integer, string, what it is, and then some of the information, like this is a catalyst. It's been up for, 38 days. The description of it, it's a Cisco, and so on, right? So all the information that might be a reference. However, dissecting this data and analyzing may be a little bit challenging, so it provides something like this as well. And this is really nice because, graphs, you can, with one snapshot, you can take a look at quite a bit. So maybe you have a router over here, and then this is in octets. So the interface has received these many octets over time, and you can see that. So that's the octets over time for a specific so the specific OID that you're looking at, and so on. And here, there's more information, it starts to get into like Excel, you can see like more reports and so on. So the sky's the limit on these, right? So you can always make, and then there's the history, started in the 80s and so on. You can take a look at how it has gone over time. And that's it. That is Simple Network Management Protocol. I hope that makes sense. Let's actually, since I finished the lecture, let's just start the lab for SNMP on this Wednesday. That way I can keep it as one module. Then we have the exam a week from today. And then the Wednesday next week, we can do user account management. So that way, yeah, so that's the plan. So yeah, we're gonna stop here for today, and I will see you guys on Wednesday to work on the SNMP lab. All right, I'll say a couple of minutes if you have any questions. I'm gonna pause the recording.